Okay, so here we go with absolute value functions. Absolute value is a type of piecewise linear function that's written like this. Okay, so the parent function of this is down here. Here's the parent function. Okay, so if I look at this, the parent function is here. This right here, right, that part right there is called the vertex. Okay, it's where it changes direction. It is either the maximum or the minimum. And if we have y equals the absolute value of x, the absolute value of -5 is 5. The absolute value of -4 is 4. -3, 3, 2, 1, 0. So if I look at this, I have -1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Look at that right there. -4, -4. -4, 4. -3, 3. -2, 2. -1, 1. And then on this side, we've got a line of symmetry, and we've got the same thing. So this is 1, 2, 3, 4, 5. Okay? It does make a V shape. The domain is all real numbers. Range. So on the range on the parent graph on this one, all non-negative numbers. So if I was to write that, I would go, it goes from, oops, I didn't mean to do that. It goes from 0 to positive infinity on this one. Also, if I wanted to write it as a piecewise, okay, if I look at this, when we start at 0 and include 0, that has a slope of 1 is a y-intercept of 0. And if I come here, I have a y-intercept of 0 and a slope of 1. Up 1, over 1. Up 1, over 1. Up 1, over 1. Now, this other part, the other part of the piecewise, this has a slope of -1. Okay? I'm going to pick a different color. Okay. Up 1, yes, but it goes to the left, so that makes a -1. Up, and then you go the negative direction, and the negative direction, and the negative direction. And so it is a piecewise function. Okay, so now when I draw this parent graph, I always like to draw my parent graph. Oh, that was really ugly, but that's okay. So this says that I'm going to go down 3. So I just take the vertex and I go down 1, 2, 3. And I still have a slope of 1. And on this side, a slope of -1. And voila. Okay, again, I'm going to draw my parent graph on this one. And this one, okay, so remember when it's inside, it's already this, and then I'm going to put in my number. So that's a +4, so that means I'm going to go to the right 4. So 1, 2, 3, 4. This is going to be my new vertex point. And I have a slope of 1, and I have a slope of -1. Okay, again. this says that I'm going to go to the right 2, and I'm going to go up 3. Okay, going to go to the right 2, 1, 2, and go up 3, 1, 2, 3. That is my new point, and I have a slope of 1. Did not like that. Slope of 1. Slope of -1. And there we have it. Okay. Now, this one says, identify the absolute value functions from the graphs. Write an equation of the given graph. So we're going to put it in this form. So what happened? Okay, so we started off with the f of x, and what did it do? It moved over 1. So g of x equals, the a value didn't change. We still have the same slope, x minus, it didn't go up at all, so we know that we're just doing something to inside the absolute value. So what did I do? I went 1 time. I should have done that in a different color. Went 1 time to the right. This over here. Okay. I went down 1, 2, 3, 4, 5. So I went down 5 and went over 1, 2. I went to the left 2. I have the slope is the same. Up 1 over 1, up 1 to the left. Okay. So now I just put it into this form. G of x. The a value is the same. My slope's the same. So I put my x minus and I put a plus. Okay, so it says I went to the left, so that's -2. So 2 negative would make that into a plus sign. And then for 5, going down is negative, so this should be -5. Okay, dilations. Now see, dilations are sometimes a little more difficult to do. So I'm going to go ahead and I'm going to graph my parent graph. It's a little off. Still a little off. There we go. That looks better. Okay. So I drew that. Now what this is telling me is on the outside of the absolute value. So if it's on the outside of the absolute value, that means we're doing something to the y's. So I'm taking half of the y value. So that's going to get me 1.5. This is going to get me 1, 0.5, 0, because anything times 0 is 0, 0.5, 1.5. Nope, try that again. How about that's just 1, and this one's 1.5. So I'm going to go to 0, 0 again, so it's right here. And if I'm doing -1, I go to 0.5. So -1 is 0.5. And then -2 is 1. And -3 is 1.5. -4. Okay. And if I'm coming over here, 1 is half, 2 is 1, 3 is 1.5. 4 is 2. Well, that was horrible. There we go. And there we go. Now remember, if it's on the inside, then it's going to be the opposite operation. So right now it's times 2, but the opposite operation would be divided by 2. So this is going to take, nope. I'm going to take x and I'm going to divide it by 2. So this is negative 1.5. This is negative 1. Negative 0.5. 0. 0.5. 1 and 1.5. Over here, these are all the same. The y values didn't change. They stay the same. So I'm going to plot my points. Oh, I forgot to do my parent graph, so give me just a second to do my parent graph. And you really should be using a straight edge while you do this. It's nice on mine because it just automatically does it. So negative 1.5, 3. Negative 1.5, 1, 2, 3. And then 1.5 is also 3. Okay. Then negative 1 is 2. So negative 1 is 2. 1 is also 2. And 0.5 is 1, and negative 0.5 is 1. And then we have 0, 0. We've got this. And we've got this. And there you go. So watch out. Differences in dilation. Although a on the outside and an A on the inside appear to have the same effect on a function, they're evaluated differently, and the difference is more apparent when the function is dilated and translated horizontally. For a function with multiple transformations, it's best to create a table. Right there we have a table. So again, whatever's on the inside, we're going to do the opposite operation. So that means instead of dividing by 2, we're going to multiply by 2. I'm going to get negative 6, negative 4, negative 2, 0, 2, 4, and 6. So I'm going to come over here, and I love doing my parent graph first. It's always nice to do the parent graph in a different color, but you don't have to do that. So negative 6, 3. 1, 2, 3, and 6, 3. Negative 2, negative 4, positive 2, 4, positive 2, negative 2, negative 2, 1, and 2, 1, and then 0, 0. And use a straight edge. Well, that didn't work very well. Is it working? There we go. That's good. Okay, so then if it's on the outside, it goes to the y value. And we just multiply 6, 4, 2, 0, 2, 4, 6. Okay? I'm going to do the parent graph. And again, one of the two lines I always do a different color to. So negative 3, 6. And 3, 6. And negative 2, 4. 2, 4. Negative 1, 2. And 1, 2. And 0, 0. And here we go over here. And there we have it. Okay. Write an equation for each graph. Okay. So on this one, well, 0, 0 stayed the same. 1, I can't really tell what it's doing. Let's see, 1, 2, 3, 4. 4 looks about halfway, doesn't it? It's about, sorry, my voice. Okay. Now, when we do this, we can actually change or decide whether or not we want to do it on the X or we want to do it on the Y. And it would be the same, but you have to look at what you are given. And on this one, I'm going to say, let's do this. I'm going to say, what am I going to say? At 1, 2, 3, 4, negative 4, it's halfway up. So that means at negative 8, it would be all the way up. It would be at 1. So I'm going to say, we could say g of x equals 8x, because if we were to do negative 1, 0, 1, and we did, this is x, this is y, if we had that, it would be an eighth of that. So this would be 1/8, negative 1/8. And if I had put in a negative 8 and multiply that, wouldn't that be negative 1? So that's what I'm going to go with that one. This one, it looks like a vertical. And this looks like a vertical change. So I'm going to put it on the inside. So g of x equals, not inside, sorry, outside. And this looks like that this would be what? 1/6? Because when we have x at 1, it looks like at the 6th, 1, 2, 3, 5, at 6 that it would hit. Oh no, not 1/6. How about 6? Is that right? Okay, so here we now have graphs of reflections and transformations. So reflecting, remember, if it is on the outside, if it is on the outside that you're reflecting over the y-axis, if it is inside, nope, I just messed that up. If it's on the outside, it's over the x-axis. If it's on the inside, it is over the y-axis. So what does that mean? Well, if it's over the x-axis, if we're going over this axis right here, this point to this point, didn't the y values change to the opposite? And if it's on the outside, that's when we change the y value. So that's why it's like that. Okay, so we're going to come over here and get rid of this, and we are going to draw our parent graph like we should always be doing, with arrows and making it with the straight edge. So on the inside, I'm taking x and I'm subtracting 3. So -6, -5, -4, -3, -2, -1, 0. Over here on the y, remember you have this right here. So I'm taking -y and then I'm adding 5 to it. So -3 and we're adding 5. So that's going to get me to -2 plus 5. Try that again. Why did I do -2? Why did I do -3? Oh, I was right. -3 plus 5 equals 2. -2 plus 5 equals 3. -1 plus 5 equals 4. I shouldn't do this late at night. That would get me 5. -1 plus 5 is going to get me 4. -2 plus 5 is going to get me 3. And amazing, that's going to get me 2. So I'm going to plot these points. So -6, 2. -5, 3. -4, 4. Then I have -3, 5. -3, 5. And then I have -2, 4. And -1, 3. And 0, 2. And there we are. Okay, so this next one, okay, is all on the outside. So that means I'm doing this to the y value. So -3/4 y. Oh, these aren't pretty numbers. So -9 over 4. -3 over 2. -3 over 4. 0. -3 over 4. -3 over 2. -9 over 4. This is the same thing as -2.25. -1.5. -0.75. 0. 75. Oh, I just realized this is making lots of noise. So I come over here, I draw my parent graph. And I draw my parent graph. So then, make it a little bit smaller. So I have -3, and it goes to -2.25. 2.25. And that would be 3 at -2.25. And then I have -2 at -1.5. +2 at 1.5. And then I would have -1 at 0.75 and 1 and 0, 0. There we go. Okay. Awesome. And then this last one, I'm doing the inside. So I'm reflecting, and remember we have to do the opposite operation. So -3/4, -1/2, -1/4, 0, -1/4, -1/2, -3/4. Now, I'm actually going to come down here and do this, because this is actually going to get me -1. I'm going to come up here to -4, and that's going to get me -1. So this would have been 4. So that would be 4. 4. Okay, so let's do this. So -1 would be 4. So -1 would be 4. Oh, I forgot to do my parent graph. Okay. And -1. Who wants to yell at me? You should be positive. I'm sure somebody caught me in that. So 1 should be 4. -1 should be 4. 0, 0. And then 1/4 is 1. Negative. Like so. There. Okay. Now, so here we go. Let's come down here. Nope, we'll do this. So here we are. We are doing multiple things. So if h is greater than 0, the graph of that is translated h units to the right. Okay, over here, if k is greater than 0, then it's translated k units up. If a is greater than 0, the graph opens up. If a is less than 0, the graph opens down. the absolute value of A is greater than 1, then it's stretched vertically. If A, the absolute value of A is between 0 and 1, then it's compressed vertically. Okay, choose the phrase that best describes the parameters. So -5, this number right here, that's going to deal with a stretch or a, what am I going to say, a stretch or a shrink? So let's look. It's out of the side of the parentheses. It is greater than 1. So that means if it's greater than 1, it's a stretch. Okay, so we're going to stretch it. And it's going to reflect. So this is going to go here. Then it says 2. So this number right here on the inside, that means it's going to go right 2. Okay, it translates right. Then this number on the outside says we're going to go up 3 and translates up. Okay. So on this one, is there a reflection? No. Is there a horizontal translation? Yeah, right here. We're going to go left 1. Is there a vertical? Yes, we're going to go down 4. Then it says domain and range. The domain is all real numbers, so it's going to go from -infinity to +infinity. The range on this, okay? So because it doesn't reflect, that means the vertex point is right here at -1, -4. So that means that it's going to look like this. This right here is the lowest point that the range could be. So the y value, the lowest point, is -4, and it would go up to +infinity. Okay, so look at this. Don't assume that these two are exactly the same. Okay, don't assume that. Let's do this. Okay, on the inside, remember we do the opposite when it's on the inside. So we're going to add 5. So that's going to be 2, 3, 4, 5, 6, 7, 8. On the y, it's the stuff on the outside. So we have 2y plus 1. So that's going to get me 6 plus 1, which is 7. 4 plus 1, which is 5. 2 plus 1, which is 3. 1. So on this one, these numbers are the same. So it's just going to be 3, 5, 7. So let's plot these. Well, first let's plot our parent graph. That's not a pretty one. Why is it? It is not cooperating. It's better. Okay, so I want to do 2, 7. 2, 7. And then 8, 7. And then I have 3, 5. And I have 7, 5. Then I have 4, 3. 4, 3. And I have 6, 3. And I have 5, 1. And there we are. Oh, nope, I messed up. 5, 1, 6, 3, 7, 5, 8, 7. Why is that not? Oh, it just looked weird. And there we go. Then over here, now you have to be careful on this one. Okay? So if you remember in the notes that we did, the shift has to come first. So I have to do in parentheses first. I need to do the x plus 5. Then I can multiply it by the 1/2, because remember this is opposite. So I have to do this first. So first I'm going to have, I have 1/2, and that's going to be of -3 plus 5. So that's 2. So that would be 1. So 1/2 of -2 plus 5. That would be 3. So 3 over 2, or 1.5. This one would be 1/2 of -1 plus 5, which would be 4. So that's 2. 0, so that's 1/2 of 5. So that's 5 over 2, or 2.5. If I plug in 1, I have 1/2 of 1 plus 5. 6, half of 6 is 3. Do you notice this is going up by a half each time? 1/2 of 2 plus 5, which is 7 over 2, which is 3.5. Can I just say it's 4? And then over here, I take y plus 1. So that's 4, 3, 2, 1, 2, 3, 4. Okay, so I come over here, and I'm going to draw my it's close enough. Still don't like it, but it's close. Okay, and then here, 1, 4, 1, 4, and 4, 4. And then I have 1.5, 3, 1.5, 3, and I have 3.5, 3. Then I have 2, 2, and I have 3, 2, and then I have 2.5, 1, like so. And voila. Now, do they look the same? Well, they kind of look the same, but just look at the vertex. Oops. Vertex point. The vertex point here is not the vertex point here. So they are not exactly the same. Okay, the domain on this, the range on this one, well, actually, they both go down. Oh, they both go down to 1. So 1 to positive infinity. Okay, almost there. So again, when you have them like this, you have to do the x first, so x plus 6, then divide it by 3. So 1/3 of negative 3 plus 6, that would be 3, so that would be 1. 1/3 of negative 2 plus 6, so that's going to be 4, so 4/3, and 1.3 repeating. And then this would be 1/3 of negative 1 plus 6, which would be, that's 5/3. So that's going to be 1.6 repeating. And this would be 1/3 of 6, which is 2. And then if I plug in 1, I get 1/3 of 1 plus 6, which is 7/3, which is 2.3 repeating. And I get 1/3, and I get 2 plus 6, which is 8/3, which is 2.6 repeating. And then 1/3 of 3 plus 6, which is 9. So that'll be 3. So 1, 3. Oh, I forgot. I have to do my parent graph. Come over here and do my parent graph. And then I go 1, 3. 1, 3, and 3, 3. I got 2, 0. And then this one. So we are adding, and we're adding 3, so that's going to be 0. 1, 2, 3, 4, 5, 6. Over here we're taking the opposite of y and adding 5. So that's going to be negative 3 plus 5, which is 2. Negative 2 plus 5, which is 3. Negative 1 plus 5, which is 4. This would be 5. 1 plus 5 is 6. How about negative 1? I forgot to take the negative. That's 4, 3, 2. So I'm going to plot these points first after I get my parent graph on here. Okay. I'm going to do green. 0, 2. 1, 3. 2, 4. 3, 5. 4, 4. And voila. Okay. Buildings. Determine the absolute value function that models the shape of the Palace of Peace and Reconciliation. So we look at this upside down. So I have a vertex point of 0, 62. It's upside down, so we know that there's a reflection. Okay. So if I do this, if I look at this, what is the slope of this line? So if I do the slope on this, I get 0 minus 62 over 31 minus 0. So the slope is negative 62 over 31, so the slope is negative 2. So g of x equals negative 2, absolute value of x, and then we move it up 62.